Hey subscribers, welcome back to another episode here where we're talking about some electric power problems. Now, I'm going to show you how to do 3 of these problems, and then I want you to do the remaining 3. So there's a total of 6 problems. And with electric power, I always like to identify the formula that we are going to be using. And the formula here is I for current equals P for power divided by V for volts. So again, we're going to utilize this formula throughout all of these problems. Again, I'm going to do problems 1, 3, and 5 and expect you to do the remaining 3 problems. So again, always start out with your formula and identify here what you know and you don't know. So here it says in number 1, an electric mixer draws 200 watts of power and the mixer is plugged into an outlet across a voltage of 115 volts. What current is in the mixer's circuit? So if you can't remember, the current is the variable that we express as I. Now our P for power is going to be in watts, so we have 200.0 watts. And then our voltage there, it is in volts, and that's 115 volts. Okay, so we know 2 of the 3 things. We can identify the I for amps. So we plug this in, 200.0 watts divided by 115 volts. So we do this. We put 200.0 divided by 115 and we press enter. Rounding to 3 significant digits, we get a value of 1.74. Now, you could put this as watts over volts, but more commonly, we have a big A for amps. Okay, so that's how you would solve for current, solve for that I variable. Let's go down to number 3 and solve for a different variable. So it says here in number 3, a certain high-speed train is powered by 64 electric motors, 1 motor for each axle of the car. The power output of each motor is 185,000 watts. The current provided to each motor from the overhead power lines is 7.4 amps. What is the voltage across each motor? So again, we're going to utilize that same formula of I equals P divided by V. So again, I is current in amps, and so if we read close, those power lines are providing a current of 7.4 amps. Now, our power here is a really big number from these motors, 185,000 watts. And this is a comma there. And then our volts is what we need to go find. So we're going to have to do a little algebra here. So our amps here is 7.4 amps. Equals our power, which is 185,000 watts, all divided by our V for volts. Now, when we have this scenario, remember we pretend that these are equivalent fractions and we cross multiply. So we take 7.4 amps times our V for volts, and then we take 1 times 185,000 amps, or excuse me, watt. And to solve for V, to get V by itself, we're going to divide each side by 7.4 amps. Okay, so in my calculator, I'm going to take 185,000. And I'm going to divide that by 7.4. And when I do this, I get a value of 25,000 volts. So again, our V for volts equals 25,000 volts. Okay, so I've shown you how to solve for I current and V volts. Let's turn to number 5 and solve for P for power. Okay, so number 5 here, it says a refrigerator uses a current of 0.62 amps and has a voltage of 116 volts. We want to know how much power does the refrigerator use. So once again, we're going to use this formula of I equals P divided by V. And our I is always expressed in amps. So we have 0.62 amps. Our P for power, it says in our problem, hey, go find that. And then our V for volts is 116 volts. Okay, now we have 2 of our 3 variables. We can plug this back into our formula. So 0.62 amps equals our P for power, all divided by 116 volts. Now again, we get to the point here where we can use that cross multiplication. So we assume we put that 0.62 over 1. And so all we need to do is take 0.62 amps times 116 volts. And let me write that down. So 0.62 amps times 116 volts equals P times 1, which is just P. And so in our calculators, all we're going to do here is we're going to take 0.62 amps times our 116 volts, and we get a value. We get a value here. I'm going to round to 3 digits, 71.9 as our watts. P, remember, is expressed in watts. Okay, so I've done half of these. I want you to do problems 2, 4, and 6. So again, you do problems 2, 4, and 6. Hope you've enjoyed this episode. And if you haven't already, make sure you subscribe.